This question asks us to analyse some data, make a few predictions, and also do a whole regression analysis. So it might be an innocent looking question from the front, but it's actually quite a complex question. You can do everything in this question though, so let's go through it step by step. Now the first thing we need to do is put our data into our calculators and make a scatter plot and have a look at the quality of our data. So let's do that. We'll get out our calculator, we will go to the menu and statistics, and we'll start entering in our data now. So here's our data in our calculator, and we're going to find the equation and have a look at our data. So remember, I go calc and regression and linear regression. Now, it needs the explanatory and the responsive variable. And it's always easier, would you believe, to start with the responsive variable. So we have a look here and we say, okay, we want to predict the mental ability. It's always phrased as we want to predict the responsive variable. So mental ability is a responsive variable. So I'll put M for mental ability, which leaves S, the speaking age, for the explanatory variable. Now I'm going to go okay, and I'll find out my equation here. So let's get this stuff and we'll write it down on our page. Now I know I said I'd write it on the page, but I've been a little bit naughty and I've just copied it straight down. So this means we know now we can have an equation of y equals a plus bx, so that's 107.3 plus b, which is plus b is negative 1.01 times x. So that means my equation for the regression line here will be y, which is the mental ability, is 107.3 minus 1.01 times the speaking age. Okay, and that's the equation we're going to work with. Now, to do my regression analysis, I also need to have a look at R and R squared. So my R is negative 0.60. This means it's a moderate and negative relationship. So let's have a look now in the calculator, making a scatter plot to find out whether it's linear or not. So we'll go to our calculator where we have this data, and then we'll go in here and say, I want a scatter plot. I want it between my variables of speaking age and mental ability, and I'll set that, and then I'll sketch the scatter plot. And you can see here are my dots. This looks relatively linear. There's no clear pattern, even if there's a slight one. So what that means is knowing that I can write here that it's linear. Now, it's always good if it's linear, because remember, this linearity is one of the assumptions we make whenever we talk about R. So there's my response to my correlation coefficient. The next thing I can have a look at is the coefficient of determination, which is 0.36. I might write that down. 0.36 gives me 36%. So that's always good to keep in mind. And now I've pretty much used my calculator information. Now the next thing we need to do is we need to interpret these coefficients here. So the 107.3 and the negative 1.01. We need to interpret the Y-intercept and the gradient. And the way we do that is by using a couple of phrases that you will definitely use again. So this is gold, what you're about to see. Here are my phrases. The gradient's interpretation is here and the Y-intercept is here. All you need to do is know how to fill in these gaps. The rest of the sentences won't change regardless of the situation. So the first thing we're going to interpret is the gradient. The gradient, remember, is this negative 1.01. So here I could write the gradient for this relationship is negative 1.01. This means that for every one, whatever unit this is, so for every one increase in the explanatory variable, now the unit is month, so I'll write that. In the explanatory variable, so this is speaking age, the regression line predicts that the mental, we'll just call it the MAB, the mental ability score, will increase or decrease. Now, a negative score means it will decrease. A positive means it will increase. So what I'll do is I'll get out my pen and I'll cross out the increase in this case. So it means that for every increase of 1 in my speaking age, then the mental ability score will decrease by whatever the number is, 1.01 units. And that's going to get a big tick from the examiner. The next thing is my Y-intercept. Now my Y-intercept, which is here, 107.3. Now what that means is that if we had a explanatory variable, so a speaking age of 0, so this means that a baby's born already talking, that was wonderful, mum, then we would expect the responsive variable or the mental ability score to be, so I'll write again, the mental ability score to be 107.3, and that's how we interpret the Y-intercept. Now these two phrases are always the same sort of words. So if you use these phrases, you're in great shape when it comes to making the examiner happy. So now what we're going to do is we're going to make our predictions. And our two predictions are for a 12-month-old speaker or for a 4-month-old speaker. So let's do that. A 12-month-old speaker, that means the speak age, or X, let's just call it X, is 12. Therefore, let's work out our mental agility score. So if you want, our mental agility score will equal 107.3 minus 1.01 times 12. And we'll pop that into our calculator. And we'll just go to our main and write 107.3 minus 1.01 times 12, and we get a score of 95.18. So there's our mental ability score when the speaking age was 12 months. If we have a look at the speaking age of 4 months, we can do exactly the same sort of thing. So the mental ability is 107.3 minus 1.01 times 4. And again, when we get at our calculator, if we really want to be clever, because we're using the same equation, we can just substitute that in, and we get a score of 103.26. And there we've calculated our expected mental agility scores according to the speaking age. Now it's worth keeping in mind that we calculated an R-squared score of 36%, which means 36% of the variation in the mental ability score can be explained by the variation in speaking age. This doesn't mean that our numbers are wrong, but it means there are lots of other factors that might go into constructing the mental ability score of these kids. The final thing we need to do is comment on the reliability of the predictions. Now, a phrase like this, it's worth keeping in mind, is always asking about interpolation or extrapolation. And we need to keep those two things in mind. Now, this first question asking about kids who first started speaking at 12 months, we've got some data in our data banks that already relate to kids who started speaking at that age. So if you have a look, 10 months, 9 months, 11 months, 8 months, they've all started speaking at around that age. So we can directly compare that, which means that this is more reliable And it's called interpolation because this number of 12 months of speaking is within our data range. In contrast to that, if we have a look at a child who first starts speaking at 4 months, there's no data that we have there that we can compare it to. So we don't know if this is correct or not. It might be spot on. We're not talking about accuracy here. We're talking about reliability. And this is less reliable because we have no data in that range. This is extrapolation. And because we can never compare the data with extrapolation to data we already have, we just don't know how good it is. It might be perfect, but it's not reliable. And that's why when we comment on the reliability of our predictions, interpolating is far more reliable than extrapolating.
If you found this video helpful, please subscribe or like. Thanks.